So let's look at this example and let's look at how we can use the standard algorithm to solve this. So let's set up our problem using the standard algorithm. We would have 2.4 times 43. So as I'm looking at this, I'm wondering if there's a way to get rid of this decimal so we could just make it a whole number multiplication problem. So one thing I could do is I know that if I multiplied 2.4 times 10, this decimal, because each digit would shift forward one place value, that would become 24 instead of 2.4. So if I multiply this number by 10, it changes this problem to a whole number problem, which would be 24 times 43. Now, let's work this problem out and then see what we need to do to get this decimal back. So 3 times 4, that would give me 12. 3 times 2 would be 6, plus 1 is 7, or 72. Drop a 0, because now I'm moving on to my 4 tens. 4 times 4 is 16. And then 4 times 2 is 8, plus 1 would be 9. So now I need to add my partial products. Which will give me 1,032. Now, I need to remember that I multiplied by 10 in order to turn this into a whole number multiplication problem. So now what do I need to do to bring my decimal back? Well, I can divide by 10, and that will shift each digit backwards. And we can imagine that in this whole number, 1,032, there would be a decimal right here after our last digit. And if we divide by 10, each digit would move backwards, which means this decimal would move to here. So our answer would be 103 and 2/10. So just like our area model, we got 103 and 2/10. So what did we do to make this problem a little easier? Well, we multiplied by 10 to get rid of the decimal. That changed this to a whole number multiplication problem, just 2 digit by 2 digit. We solved and got 1,032. In order to bring that decimal back, we had to do the opposite of multiplying by 10. So we divided by 10. We know that there's a decimal behind that 2 if it's a whole number. When we divide by 10, each digit shifts backwards in the place value chart, which makes this decimal go forward, and it ends there. So our answer is 103.2. And if you think back to the first problem, we estimated by rounding the factors, and we found that our estimate should be about 80. So 103, that's pretty close to 80, so our answer is reasonable, so we can assume that we're correct.